Okay, example 24 deals with parametric integration. So the result that you use for integrating parametric equations is y, which is multiplied by x differentiated, so dx dt, and then the limits need to be the values of t at the 2 points where x is equal to 0, x is equal to 2. So imagine this one here. If it was a fraction, that would cancel and you would have been left with y dx that needs to be integrated, which you recognize from area integration before or finding the area before. So over here we just need to find the product y dx dt. So this is y is 1 over 1 plus t, and dx dt is 1 plus 2t. So it's 1 plus 2t over 1 plus t. So in a moment we're going to integrate 1 plus 2t over 1 plus t dt. The limits. So what I need to do is find the values of t at those points here. Now you are told that t is greater than or equal to 0 for this particular curve. So that will help us with finding. Now this point over here, I know that the value of x is definitely equal to 0. So if I make t plus t squared equal to 0, that gives me t is equal to 0 or t is equal to minus 1. Since t cannot be equal to minus 1, it has to be 0 at the lower limit. And then the second one, x is equal to 2, so that gives me t plus t squared is equal to 2. So t squared plus t minus 2 is equal to 0. So let's try and factorize it, which should be nicely done. Yeah, that works. So you've got two solutions, minus 2 or 1. Again, you're going to pick 1 as this one is rejected because it's negative. So the upper limit is 1. Now, how would you integrate this? One way of doing it is to recognize it's the simplest partial fraction, so you can do dividing. I would recommend, though, using substitution. That's what I'm going to do. So using u equals to 1 plus t. The reason I'm replacing the denominator, I always say replace the denominator, the part that if you were to bring it to the top would get an awkward power. Differentiate it. And then you can have dx being replaced by du. Okay, 1 plus 2t will be in the numerator, so I'll have to replace t with u minus 1. So I have 1 plus 2 lots of u minus 1, and that gives me 2u minus 1. There you go. So the integral, okay, and obviously the limits, new limits. So I need to change these to u. So u when t is equal to 0, that gives me 1, and u when t is equal to 1 will give me to 2 using this substitution. So these are the new limits, 1 and 2. 1 plus 2t is 2u minus 1 over u, and dt was substituted, can be substituted by du. Let's separate this, so it's 2u over u minus 1 over u. So that gives me 2, which integrates to 2u, and that gives me ln of u. Putting the limits of 1 and 2, these are the new limits. Let me just do it on the next piece of paper. So you're going to have 2 times, let's just double check, 2u becomes 2 times u minus ln 2 minus 2 times 1 minus ln 1. So it's 4 minus 2, which is 2, ln 2 minus 0, so it's just minus ln 2. And it's done.